Hi, this is Ramu, Associate Professor, Department of CSC, Institute of Aeronautical Engineering, Hyderabad. In today's class, we are going to see the problems, the topic of loop control statements. Here, I am going to take the two programs and I am going to show you how we are going to implement in the different kinds of loops. See, here, today, we are going to concentrate on the two programs. First one is the GCD of given numbers and prime number. So, GCD number, I am going to solve in the three ways, using for loop, using while loop, using do while loop, right? And as well as the same thing, prime number using for loop, using while loop, and using do while loop. See, first we'll see the concept of the GCD of given number. What is a GCD? Means greatest common divisor. For example, if you consider two numbers, 24, okay, 24, and the next number is 6, right? We take here instead of this, 30 and 8. These are the two numbers. What is the GCD of these two numbers? So GCD means first you can find the factors. So what are the factors of 30? So 1, 2, right? Next 3, next 5, next 10, next 15, next 30, right? Next, what are the factors of 8? So 1, 2, 4, 8. Here, your task is to find the largest common factor. That is a GCD. Largest common factor. See, here is a, so here if you have the 8, no, 4 is no, yes, 2. So 2 is the, right? So this is the non-effective method. If you want to find the GCD of given numbers, I'm going to one more method. What is that? See, the two numbers are there, 30 and 8. 0 and 0 and 8. 8 is comes to here. So 30, 8 3s are 24, right? And you'll get 6 here and 8. So 6 1 ja, 6, 2 here, 6, 6, 2 3 ja, 6, 0. When the 0, you'll stop the process. So this is the way you're going to find the GCD of given number. This is the effective method. This is the effective method. No need to find the factors and everything. So this goes to big O of n time complexity, but it is a very less. Right? Almost you will get constant time. Right? So let us implement how we are going to implement this method, effective method. Here we have two numbers. Just take that int of a equal to 30 and b equal to 8. Right? First we will implement using while loop. Finding the GCD of given two numbers. What I did here? See, first what I am going to do here. So whatever it may be, 30 and 8, 0, right? So 0 and 8, right? See, the 30 is comes to here, right? Yes or no? And a value. So for example, this is a and this is B. Sorry, the reverse, right? So this is B and this is A. And after that, what happened? This value is B value is goes to A and A modulo division value is goes to B. Right? Yes or no? So what is this value? This value is, so A modulo division B. Yes or no? This value is A value, right? This value is B value, right? B is comes to A. Right? See, if you implement the concept, while should repeat this loop until you will get until you will get modulo division value is 0. A modulo division B is not equal to 0. Then you need to repeat the process. Here what I need to do? I need to find. So what is the modulo division of these two values? For example, K equal to A modulo division B. Right? And next A equal to B. B value is changed to A. And next B equal to K. That's all. Just print your result. The result is available at which variable? Exactly. It's a B variable. It is available at the B variable. See, if you run this code, yeah, what is the problem here? K is undeclared, right? Yes. Should declare the K value. And one more thing. Yeah. Here also I forgot the semicolon. So 2 is the answer. Got it? Even you change this value as 18. So 18 means what is a 6, right? Common factor, common highest factor is 6, right? Right? So how you solve that value, that result? See, for example, here if you consider 18 and 30, right? 18 1 ja 18, right? 12 will come here. So 18. So 12 1 ja 12, right? You will get here. What will you get here? So 6 2 ja 12. 0. Got it? And how we are going to solve the same problem using for loop? See, for loop, how the for loop looks like? For loop contains 3 parts. Yes or no? The first one is the for initialization, condition, and increment decrement. But as our program, we didn't require any initialization and also we didn't require any increment decrement, right? Then how are we going to apply this for loop? Means see, the 2 parts you can write simply empty null. For inflation is empty and condition is empty. Now you can check it. Our program is over. See, 6 is the answer, right? Here you don't require any initialization as well as you don't require any that one also. Is this clear? Next, how we are going to implement this using do while loop? See, what is the difference between while loop and do while loop? Do while loop, it executes at least once in their lifetime, right? It executes once in their lifetime. When it executes once in their lifetime, but initially the values are already, it's a factor of that one. For example, if you give 2 and 4, what is the output? 2 is a GCD, right? 2 is the GCD, right? Yes or no? So for that situation, you didn't work out this kind of solution. Then how are we going to solve this problem? Then this time, so even still you are looking such kind of methods, such kind of do while. Then simply you can use this do while, right? So see, while of what I'm going to do here, while of 1. You know that what is the meaning of while of 1? It's infinity, right? It is infinity, right? Is infinity, right? So see, if k equal to 0, then break, or that's all. A. So when the k value is 0, you need to stop the process. That's all. Then you can run this code. 6, right? This is using do while loop. right? So even the first values, even it contains 4 and 2. Also, we didn't get any problem. See, 2 is the answer. Already break. What is the purpose of the break? To terminate the loop. To terminate the loop. To terminate the loop. Is this clear? This is the GCD using 3 variations. Right? Is this clear? And next thing. Prime number. What is a prime number? So prime number is the definition of the prime number. A number is divisible by 1 and itself is called as a prime number. Yes or no? A number is divisible by 1 and itself is called as a prime number as per the definition. So as per the definition, it is divisible by 1 and itself. Means if a number has only 2 factors, then it is a prime number. Yes or no? A number has only 2 factors, then it is called as a prime number. Right? So from that concept, we are going to implement the prime number concept. See, here what I am going to do, int a, b, for example, a equal to some number, so otherwise n equal to some 12. Right? You know that factors, factors finding. So I equal to some value. Right? First, I am going to implement it using while loop, and after that I come into the for and as well as the do while. See, the first thing is I need to check is the 12 is divisible by. How I am going to check? So what is my first concept? 12 is modulo division 1, 12 is modulo division 2, is 12 modulo division 3, is 12 modulo division 4, and so on is a 12 modulo division 12. Right? When it is divisible, I am going to use a counter. Each time I am going to count that one. Right? If the count value is equal to 2, then this is the prime. Yes or no? Right? So here, if you observe, see, I'm going to start my I value with 1, right? And while, and I require the count also to count the number of factors. C equal to 0, right? While n I is less than or equal to 12. So up to 12 I need to check. So if n is modulo division I is equal to n is modulo division I is equal to 0, then means I is a factor. Then that means, so you just increment that value C plus plus, right? If it contains only 2 factors, then print prime, else printf, right? So due to that Python, I forgot all things. Yes, not prime, right? If it contains 2 factors, then it is a prime. Otherwise, it is not prime. Right? Let us check what it is going to display. Yes, here. Yes, you forgot one more thing. You need to increment that I value, right? So each time you need to increment that I value. Otherwise, it goes to infinity. So after that increment, you just use I plus plus also, right? It's not prime, right? For example, if you consider that 19, it's not prime. Why? 19 is a prime number, right? So we did some mistake somewhere. What it is? See, you just check that what is the C value here. So I n modulo division I is equal to 0, right? So we just use that. What is my C value? Just so this is a debugging. So called as debugging. We're just checking that not prime. It is going to take that one. C equal to 1. Less than or equal to. Let us check. It's prime, right? And we'll check that with the 12. Let us see what it is going to display. Not prime because it contains the 6 values, right? C++ and I++. Got it? So this is the way you're going to implement the prime number. Even if you check the 5 also, it's prime. And 29 also, it's prime, right? 39, you can check with 39 also. So whatever it may be, 39 is not prime, right? Let us check. Yes, something problem with this code. What is that? N modular division I is equal to 0, right? Now you can check that it is a prime, right? So you just check that the factors of every time. What is the factor of the particular value, right? Debugging is very important. So don't consider that the sample input. So it contains two factors. It has 2 factors. 39 is a 2 factors. Only 2 factors it has. So 39 is divisible by 1, and one more thing is 13 also, right? Yes or no? 13 also, right? Yes or no? 13 also. So I is less than or equal to, here you need to change the n value. Please note this. That is the error. It's not prime. Got it? Here he used 12. That is the problem. Here you can use that 59. Prime number. Is this clear? Here you just use 12. That is the reason you're getting an error. Right? Even you can use the double equal also here. Right? Is this clear? Now, how are we going to convert this program into the for loop? See, if you use a for loop, so you know that the for is here and here. So first compartment, inflation is required, right? I equal to 1, and increment is also required, right? I plus plus. Then you remove this one, and you remove this one. Installation is already done, right? Now you can run this code. It is an error. I is undeclared. Yeah, you should declare the I value, but installation is not required. Yes or no? It has 2 factors. Counting the factors, if the factors are 2, then you display the value. Right? Got it? And you can use a do while also like this. Is this clear? So always try to implement a problem with the different kinds of for loop so that you will get some idea, right? How it is going to evaluate in the loop to loop. Most of the problems you are going to solve using while and for only. So do while is a very less usage. You don't need to worry, but you just remember how we are going to use a do while also. Is this clear? Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.